Alrighty then, let's try this problem. Suppose someone wants to accumulate $60,000 for a college fund over the next 15 years. That's very important. Determine whether the following investment plans will allow the person to reach the goal. Assume the compounding and payment periods are the same. So we have a scenario here. This person is depositing $50 every single month for 15 years into an account with an APR of 7%. So what we're asked to do is determine if this person will have $60,000 in this scenario in order to go to college with this particular college fund. What we need to do is take the savings plan formula, which says the accumulated amount is equal to the payment, which in our case is $50 per month, times this quantity right here that looks very confusing, but I'll break it down in just a second. So up here in the numerator you have in brackets, which means this quantity minus 1 is all together in the numerator. So in these parentheses you have 1 plus APR, which we have 7%. Again, make sure you change that 7% to a decimal, so we'll put 0.07 in there. N is the number of compounds. We have a payment of $50 per month, so it's going to compound per month, so that'll be 12. And then Y is years, so that'll be 15. So once we get all of this, we're going to subtract 1 from it. That's going to be the numerator within this set of brackets, and then that will be divided by the quantity of the APR, 7%, divided by N. Again, make sure you put 0.07 for that rate. Plug everything in. Now we're not plugging that $60,000 in yet, because this question specifically asks if this person has a goal of $60,000 but is only depositing $50 per month for 15 years in an account that gets a APR of 7%. Will they reach that goal? So we want to know what is the accumulated value in this scenario. So we're looking for A. We know the payment is $50 in the parentheses, or in the brackets, and then inside the parentheses we have 1 plus the rate divided by 12 to the power of 12 times 15 years, minus 1, all divided by the APR, 0.07 divided by 12. And so your calculator strokes are going to be extremely important in these types of problems. So let me grab the calculator. For problems like this, it's very important that you understand PEMDAS, which is your order of operations. A lot of people say, please excuse my dear Aunt Sally. The P represents parentheses. Parentheses and brackets are both the same. They're treated the same. So these brackets up here, you'll treat those as if they're parentheses, but there are parentheses inside of those brackets, so we make sure we go as far inside as possible. E represents exponents, so after we calculate what's inside these parentheses, we need to make sure we raise whatever's inside there to the power of whatever 12 times 15 is. And then M and D is multiplication and division. Those two again are done left to right, and then A and S is addition and subtraction, also performed left to right. Alright, so you see on the screen there it says round the final answer to the nearest cent as needed. Round all intermediate values to 6 decimal places as needed. So it is going to allow us to round in the middle of a problem and still consider that to be correct, as long as we round those intermediate values to 6 decimal places. So inside you get this number. Now it's going to allow us to round that 6 decimal places as needed. Personally, I would not round that. You'll be more accurate if you do not round that, but if you do round that, make sure you round it 6 decimal places. Let me show you what to do if you don't want to round it. So So instead of keeping that 12 times 15 up there, I'm just going to say that that's 180. So now, whenever I take 1 plus 0.07 and divide it by 12 and hit enter, I have this decimal here. Now, without having to round, I'm just going to take that right there and hit the raised to the power of, which is this button right here, and it's going to take that exact value of that quantity and raise that to the 180 power. Now, you could have rounded that and raised it to 180, but we're going to try to be as accurate as we can. So I recommend doing it this way. And so keep up with what you're doing. We just calculated all of this. So next, what we're going to do, we're still inside of our brackets, so we're still going to treat those as parentheses. So whatever that quantity is, which is here, we're going to subtract 1 from that. And that's what we get. So there's what it is. We're just rounded 6 decimal places. Now again, I want to try to practice this with exact values. So I'm going to show you how to perform this whole thing without having to round. Now if you want to round, it's allowing you to round 6 decimal places for any of these intermediate values. But if I want to keep this exact number right here and use it instead of using that rounded 1.848947, what I'm going to do is multiply this 50 to that 1.8. So just keep that exact value. If I just hit times, it's going to keep that previous answer, multiply that by 50. And so now my numerator is, again, just for the sake of showing the work on the sheet, I'm going to round these numbers 6 decimal places on the sheet, but up here on the calculator, I'm actually keeping everything exact. So that 50 times this, the exact number that represents is 92. Now again, we want to round 6 decimal places, so 4473. Let's see here, 1 2 3 4 5 6. So that's going to be a 7. So 447337. 447337, and then we're going to divide that by this. And so what we could do now is just hit divided by. Notice that's in parentheses, so I can use parentheses in my calculator, and it again will do the order of operations. So if I plug that into my calculator, in parentheses, I took the answer from the previous calculation and I'm dividing it by that quantity, making sure that's in parentheses. If you do not put that in parentheses, then your calculator will do the order of operations that you tell it to do. So make sure you represent that quantity in parentheses in the calculator. So now there is my final answer. My A is $15,848.11. Now I'm rounding that 2 decimal places because now I'm finished with my calculations. So the question was, will this person have $60,000 for their college fund? And the answer here would be, they're very short. And so we would say no. The amount of the college fund would be 15848.11. We'll check it, and we are correct. Now again, I use the exact numbers in the calculator. I would recommend that you practice doing it that way. Again, it will take practice, a lot of practice. But let's just see, let's look at this number here, okay, and let's see how that's affected if I were to round everything 6 decimal places like I'm showing on my sheet. And let's see how much different the answer is. So 92.447337 divided by 0.005833. It's off a few cents, right? So your MyMathLab should also accept this answer. It's almost $1 off, but hopefully you see the significance of rounding those intermediate values within a problem. All right, it will throw off the final answer quite a bit, but your MyMathLab is allowing you to do that, and it's just going to take into account the error. I recommend keeping everything exact, but if you do need to round and show your work like this, then just make sure you're rounding those intermediate values 6 decimal places. Alright, I hope this helped, and I'll see you in the next one.